Now, I've chosen this question because it's similar to ones that you will see in the HSC. Okay, we've got a loaded bridge here. We've got the truck that's actually here. We've got a whole lot of words that are going on. This is unusual for the question, but again, I've put it in here just to make sure that you are thinking. You have to think about what's actually happening here. Now, I don't believe that you'll get a angled roller joint like this, but again, just in case you do, it's going to make you think about how the process works. Okay, so if this was the method of joints, we'd actually be looking at calculating every one of these joints to work out what the loads are. And you can actually do that with this, but it gets a whole lot easier when we're using a method of sections for this sort of thing. Let's have a look at the question before we go on. Determine the reaction. Let me just start again. A dump truck with a mass of 30 tonnes is used to carry 20 tonnes of soil across a pin-jointed truss. Okay, there's a pin joint and that's the truss. In this instance, load located above F. Okay, so the truck is above F. So before we go any further with this, if I had my pen in an exam, I'd actually be drawing that load in. Okay, so I'm going to be drawing all over the exam, and I'll come here and I'll put a line down here so I know that that's where that weight is. I've done it later on here as well, but I've actually calculated out what the truck weighs. I've said assume gravity is 10. I've then done the dump truck, then done the load, and to get the actual total forces. So again, it's one of those things we need to actually label our drawings with conventional graphics to ensure that we actually know what we're doing and can understand what we're doing. Okay, so that's part of the knowns. It's part of working out what those things are, the information that we're being given. Now let's have a look at what the question says. Determine the reaction force. Okay, it's not asking you for magnitude. It's not asking you for direction. It's asking for the reaction, which is both magnitude and direction. Okay, it's quite important to know you've got to give magnitude and direction. Okay, so to determine the reaction, it's created both supports due to this dump truck. So here, this force is going to be travelling up in this direction, right? So we've got a force going that way, and then we're going to have a force here, and we're going to have like X and Y coordinates, but what we want is that resultant between the X and Y. Okay, remember that's the reaction force. It's a combination of the two. And we'll break that down later on. The next thing here, it says determine the magnitude of the force in DF. DF, which is this one. Now, excuse me, I disagree with the way that this bridge has been labelled. It's gone A, B, C, D, E, F. What they actually usually do is label around the outside, and they go in a circle, and then they come on the inside. Okay, so I apologise for this. I haven't followed this actual numbering in the equation, but just realise, as long as you can recognise what each of these are, you're okay. So, again, looking here, what are we actually doing? Excuse me. I've got my list. First thing, I've got to find global equilibrium. Right, I need to find out where this bridge is in equilibrium, and I need to find the reactions at these. Okay, so I know what they are. Right. I'm then going to cut through this member here. I'm going to cut through those three members to work out what the force is in this one here. All the way along, I'm going to come back in here. I'm going to draw free body diagrams, and I'm going to determine the direction and the sense of that force that's in there and calculate the moments. Okay, so I'm just going to run through those as well. So the method of sections is that we're going to use a combination of the sum of all forces as well as moments to get the answers. Okay, so both we're using in this process. Okay, again, like I said, I didn't draw it in here. I've got it drawn down here in the next one, but you need to use conventional graphic methods to actually get all your information in here. Okay. Again, simple math to get that down. Here's my unknowns. I'm breaking it down so I know what I'm doing. reaction at roller, reaction at pin, and magnitude of the force in DF. One step at a time and look for the easiest way forward. So as we know, before we go any further, we've got to work out the magnitude here. We've actually got to work out what's actually happening here. Excuse me. Right, so as I'm going along here, I'm taking my moments around the pin joint. Okay, so I can see here I have 26 kilonewtons and it's 6 meters away. This force will be running all the way along here, so it's 6 meters away. I have 500 kilonewtons coming down this way, so it's 12 meters away. Half of this 8 is coming directly down there. Then I've got my G-force, okay, and I know that my G-force is 8, 16, 24 meters away. Now the issue with this one is that I wanted to actually find my horizontals. Or I wanted to find these forces here. That's the way we usually calculate it out. Okay, so again, this is where the thinking has changed. I've actually set up the triangle this way so that I know that this would be 30 degrees and that's 90 and that's 60, so that I can actually start calculating out what this force is here. Okay? Sum of all forces. 26 by 6, right? 26 by 6, 500 by 12, and then G sine 60, right? Sine 60 by 24, and then that's going to get me my G. I'm sure you can work it out from there how it actually goes. Now for my J point, again, I've actually, excuse me, I now have my G, and I've got to find my X and Y at J, and again, sum of all forces. But again, look here, I'm changing that G around to make sure that I do actually get it like vertical, and this one here, it's changed again to make sure that I get the horizontal. Look, these aren't really difficult concepts. I know we keep saying it, we keep discussing it, but it's actually seeing what you need to do. It's seeing that we've got to actually change this around to get to our horizontal and verticals, and that's why it's worth drawing it. If you can draw it, you can see it. If you don't draw it, you're going to have trouble and get a little bit confused. Okay, so I've got my X and Y's there. Is that the resultant? No, it's not. I need to find out what actually happens with this in a resultant. So I've come down here and I've drawn my triangle. I've got my 166 horizontal, 256 up, and there you can see it. That's my J and that's my angle. Pythagoras for J, tan for the angle. And that's my resultant there, okay? Let's move on. Now here is the method of sections. Here's where we actually come into doing this work here. Excuse me. You can see here I've got my, my free body diagram with everything, and I have put in here my section. Now, I want the easiest way forward. If I work on this side, all of a sudden I've got this drama to play with. I've got a 500 and a 26. I've got a whole lot of different things that I've actually got to play with here, which is going to be tough work. Can be done, but hey, why do the tough way when you can do it the easy way? So what I'm going to do, I'm going to work on the left-hand side only and ignore everything on the right. I don't even have to think about it. I'm just looking at the left-hand side. So you can see here on the left-hand side, that 26 shouldn't be there. That's a mistake, right? But I've actually got here my different diagrams. I've got my 166, a 256, and the ones that I'm actually trying to find are these two. Okay, I need to find these two. So the whole idea, I've done it here, which is good. That 26 is there, it shouldn't be there, I apologise, because that's, again, it's on this side of the line, so I should have ignored it. I don't know why I put it in there. Ignore that, that's a mistake. Okay, so now I'm looking at this. And I'm wishing to actually find this one first. The reason I need to find this one is because I'm going to calculate the moments around J. again, you think about it. If I calculate the moments around J, this is on J, this is on J, and anything else on this line is on J. So I can actually ignore all of those forces, and I'm back to my easy one for my calculations. Okay, so I'm back to my easy ones. So the first thing I need to do is calculate out my angle. So, because I'm going to be working with angles. Here I've got 6 meters, right, 6 meters by 4 meters, and then I can work out that I've got an angle of 56.3 degrees in here. Right? It's just, again, like I said, I'm just getting that angle. Now I can sum my forces around this. Right? I can sum my forces around this here. So, if I'm looking at my vertical forces, I've got 0 equals 256.5. There's no other vertical force in there, so I don't have to worry about that. I've just got to worry about the vertical part of this one, which is CI sine 56.3 degrees, my angle there. Work it out, and now I've got this one here. I've got this force that sits in there. I need this force because it impacts this one. Right? I need it because it impacts this one. Because now when I'm actually going to my moments, here you can see I've got CD, which is the force I want to connect. Why isn't this up here? Come on. I have to change. No, I can change it now. Right. So here, for CD, right, I want the sum of all moments going this way equals 0, and I'm going to take them, like I said, around J. So CD, that one there is 6 meters away. So CD by 6. CI is also at 6 meters away because it is starting there. Now, if I look at, that's CI on the horizontal. Okay, on the horizontal, it's there. If I'm actually looking at CI on the vertical, you can see it's only 4 meters away. Okay, so there's that one there. It's only 4 meters away. So then I've got CI 56.3 by 4. Okay? From there, simple moments equations to get the reaction in this CD member. Things to actually understand with this. Again, here, we're looking for the reaction that's happening here. Okay, so we need a combination of both magnitude and direction. When we're looking at doing this, we're looking at the simplest way forward to get it done. The simplest way, okay? And like I said, when I come back up here, as soon as I put this cut line in, I can see that all of this stuff is just going to be too hard work, so I was only going to focus on the left here, okay? Give the sums a go. That's the best way that you can do it. Again, I don't think you'll get a question this hard, like with the need to, calculate out these sections, but you will get a sectional question in your exam, and you need to actually be able to think it through so you can work out that, right, this one here, I'm actually going to sum the forces, whereas this one here, I need to actually do the moments of the force. Practice is the best way to actually be able to see this one.